Hello and welcome to today's webinar, Leostream, Advancing Secure Remote Access. My name is Megan Griffin and I am an account executive here at Leostream. Joining me is our CEO, Karen Gondoli. Karen will be presenting our platform for you today.
Hello, everyone.
Today we'll be going over a little bit about the Leostream company and our current customers, our secure remote access best practices, how Leostream can help you, a brief demonstration of our platform, all wrapped up with a Q&A session with Karen. Please keep in mind that you can enter your questions throughout the presentation for us to review at the end of the demo. Leostream has been connecting users to IT assets for 19 years. From VDI to cloud-hosted desktops to remote access to physical workstations, Leostream connects your users to anything from anywhere on any device. So where is Leostream currently? It is in a wide range of verticals across the globe. Financial institutions were some of our first major customers, and the work we did with them led to support for a number of high-performance display protocols, which makes Leostream an ideal solution in industries such as construction and manufacturing, oil and gas, and media and entertainment. Leostream also has a footprint in education, and lately our remote access platform is being used in more and more community colleges and universities, not just across the US, but around the globe. Leostream is a flexible solution that allows you to future-proof your environment, whether it be on-prem or in the cloud, by constantly innovating to integrate with the latest technology. We have customers connecting remotely to on-prem desktops for both simple Office 360 and graphic intense workloads, as well as customers connecting up into all of the major cloud platforms. At a high level, a hosted desktop stack consists of the components you see in this diagram. Leostream provides the slices in the middle of the stack. Our connection broker allows you to define the rules that indicate which user has permission to connect to which resource, how long the user essentially owns that resource. It also provides provisioning and power control for cloud and virtualization environments, which is especially important in the cloud where you pay for running compute. The Leostream gateway, then, is the key for remote access. It connects users who are outside of the hosted desktop network to their hosted desktops without requiring a VPN connection. And it supports in-browser HTML5 connections, as well as a number of client-based high-performance display protocols. So what are some of the technologies you can use to build the rest of the stack? Leostream's philosophy, and one that is being increasingly adopted across industries, is that being able to choose from a variety of the best hosting platforms, display protocols, authentication methods, and profile management tools, instead of being locked into one full-stack solution, allows customers to build a flexible environment that works best in a way that maximizes utility while minimizing costs. Now I offer the floor to Karen to present the features and benefits of the Leostream platform.
Awesome. Thank you, Megan. Again, my name is Karen Gondoli. It's a pleasure to have you all here today. First, let me set the stage. Why should you care about remote access? Truthfully, if the pandemic had ended a month after it started, we'd be having a very different conversation right now. In the early days of COVID-19, I read a Tech Republic article that said roughly 80% of employers didn't have a remote work policy. Now, I'd like to point out that Leostream was one of that 20% that did, but that makes sense given the software we sell. For the other 80% though, I think there was always a question about how productive a remote workforce really could be. And at the time, that question made a lot of sense. Being productive as a remote worker does take a discipline that comes from practice, something we've all had a lot of experience with over the last year. But maybe more importantly, it also requires technologies that support it. The concept and practice of working remotely has been fundamentally changed by technologies like Zoom and Leostream, technologies that link together geographically dispersed workforces. Remote no longer means separate, now that we have technologies that keep us connected. Once you embrace that, those technologies allow you to do some pretty cool things. Now, Zoom and other remote conferencing technologies are a different beast. So for today, I want to focus on remote access technologies. Essentially, these technologies allow you to architect a secure, reliable, and performant way to give access to corporate resources when users are located on a different network. That's pretty much the crux of it. The first three items I list here are mostly about improving the productivity of your staff. A well-designed remote access solution provides access to the required corporate data and application for users on the move. Yeah, right now we're not moving out of our home still, but in the near future, users will be back on the road, visiting client sites, attending conferences, and the lot. A remote access solution keeps them all productive while they're on those roads. It also supports collaboration. If I'm remote, I may not be able to stand over your desk and comment on what you're working on. That may be good or bad. But there are remote access technologies that mimic that functionality, allowing multiple users to view the same screen essentially. We've been seeing those technologies used extensively in the media and entertainment industry to support post-production editing, just as an example. So those examples cover your existing staff. My third point here looks into the future. If you can make remote users productive from anywhere, you can now recruit from anywhere as well, whether that's looking for new employees, enticing your employees to stay, or if you're a university, reaching out to a new student base even. I've heard stories of people moving way out of commuting distance from their offices during these last years. If you force them back to the office, you'll lose them to another employer who won't. Flipping to the other side of the coin, let's talk about the valuable business practices that a remote access solution puts into play. The first is moving to the cloud. Now, not all data and applications are perfect for hosting in a public cloud, but for those that are, the cloud does have distinct advantages. As we've all heard, it turns capital expenses into operating expenses for one. It's also easy to expand and contract capacity as your demands and needs change. And it's perfect for supporting those first three initiatives we talked about. Even if your entire staff returns to the office, unless you have a direct or VPN connection to your cloud environment, cloud resources are inherently remote and require a remote access solution to use them. The cloud is also a great solution for disaster recovery environments and other business continuity use cases. Whether it's hurricanes, tornadoes, floods, political unrest, this wasn't the first time and won't be the last time workers can't get to our offices, and we need to prepare for that in the future. The key takeaway here, though, is that remote access isn't about allowing everyone to work from home. It's about keeping everyone working, period, no matter where they go or what they need access to. Okay. So, if remote access is the way of the future, where do you start? What are some key things to keep in mind as you design your solution? Well, many of them boil down to security. Now, keep in mind, we're focusing on the access part of the equation. Megan showed you a graphic with all the other layers and technologies involved in a hosted desktop environment or a corporate data center. Where and what data and desktops you host is up to you. Your remote access solution then sits in front of that to indicate who has access to what and from where. Multi-factor authentication is a practice we consistently see required for remote access. You might decide to allow users on your network to log in with a single layer of authentication, but remote users almost universally need to pass through MFA. If you have a corporate standard identity provider, design that IDP into your remote access solution. If you don't have a preferred MFA provider, now is really a good time to start thinking about and getting one. We're actually rolling MFA into a number of our systems here at Leostream, and I understand that MFA can be disruptive for employees, but resources that are exposed for remote access really need to be locked up behind additional authentication. And not just behind authentication, those resources should also be locked up behind access control rules. There are a variety of ways you can control who has access to what after they've authenticated. But generally, the idea here is to not give away the keys to your kingdom and allow every authenticated user to access everything. Instead, separate resources into pools, then limit access to each pool only to those who need it, maybe even limiting that access based on the time of day or only for a certain length of time. With authentication and access control in place, next is time to look at how users connect. VPNs are great, but last year taught us that they are a bottleneck on performance when they're overtaxed. If you can build your solution with a VPN-less gateway, you're going to save on cost, save on complexity, and most importantly, you're going to save your users sanity by giving them a performant connection. Speaking of performant connections, I don't call it out on this slide, but you do need to consider the protocol that's used for the user's connection, whether that's RDP or another solution that's more suited to graphics intense workloads. That protocol needs to be compatible with whatever gateway solution you choose and the tasks the user needs to perform. And there are a lot of options out there to choose from. We'll show you some of them in the demo. What this all comes down to is that your remote access solution is the perfect place to use processes and technologies that support zero trust, from authentication to access control to tracking resource usage, monitoring who is accessing what, from where, and for how long allows you to react to changes in users' behavior that may be due, for example, from bad actors. So that's a lot. Now, what do you do? How do you do that? Well, as it turns out, I'm sure you're all shocked, but Leostream can help you here. Our platform's core tenet is to give you the flexibility to choose the technologies that work best for you. That allows you to model the processes that you've defined for your zero trust remote access environment. On the authentication side, we can integrate with any identity provider that supports either the Radius or SAML protocols. SAML is great for zero trust environments because your corporate identity provider handles the user's credentials and only passes along to Leostream the user attributes that you define in the SAML assertion. The downside of SAML is that it is a web-based protocol. So what about users with other types of client devices like zero clients? For MFA from these other devices, you can leverage your same IDP if it supports the Radius protocol. And I'll show you all these workflows in the demo coming up. Beyond flexibility in authentication, Leostream gives you flexibility in hosting platforms. We integrate with the big three cloud vendors, Amazon, Microsoft, Google, various virtualization vendors, and even on-premises workstations and desktops. So that means you can create a hybrid environment that users log into once for access to everything. We've seen that having a single portal for users is really key to a good user experience. And it allows you to essentially future-proof your environment. If you want to change platforms, easy to do, and your users will never know the difference. The final bit on flexibility is for your choice of display protocol, including some that are in browser. Again, zero trust. If you don't want to install software on client devices, a clientless HTML5 connection is perfect. And HTML5 connections prohibit USB device pass-through for additional security. I'll show in the demo all the different options you have for protocols, some included with Leostream and some not. They can all be used together though, so you can pick the best protocol for each use case, whether that's someone accessing Excel or one of these post-production engineers, maybe someone who needs Adobe Premiere Pro. Now, I've talked a lot about the technologies Leostream integrates with, which may have left you wondering, so what exactly does Leostream do? Where do we fit into this? Leostream is the gatekeeper and the gateway to all of your hosted resources. In Leostream, you build the access control rules that determine how users need to authenticate, what they have access to, where they are allowed to log in from, and how long they can remain the owner of a particular resource after they've connected to it. Essentially, Leostream is your control plane, and it's a control plane with audit level tracking of who's logging in and what they're using. Now, before I move on to the demo, let me give you a quick overview of the Leostream platform and its architecture. The Leostream platform consists of the 4 components that you see here. The connection broker is the real brains of the operation. It's that control plane where you define those access control rules. The broker handles authentication and ultimately decides what the user can connect to. The broker communicates with the Leostream agents that run on your hosted desktops, and those can be Windows, Linux, Mac, makes no difference to us. The agent is critical for the audit level tracking I mentioned. It reports back to the broker when a user logs in, disconnects, reconnects, goes idle. And not only does the broker log those events so you know what's going on, but you can use those events to trigger actions. As an example, maybe you want to automatically log the user out when they've been idle for an hour. Leostream Connect is our software client, and it actually may be optional in your environment. It allows you to repurpose laptops or certain thin clients as Leostream clients. Leostream Connect is essentially a login portal for Leostream, and just like the agent, it can run on Windows, Linux, or Mac OS. But again, you don't have to use it. Users can log in from any web browser or zero clients as well. The final component is the Leostream gateway. The connection broker is your gatekeeper, and the gateway is the gateway. It provides VPN-less access into isolated networks, whether that's a virtual private cloud or your data center. The Leostream gateway does include a built-in HTML5 client that does RDP, VNC, and SSH. It also supports a number of other HTML5 viewers, as well as client-based display protocols. And again, you'll see some of this in the demo. So how does all of these components fit together? Like this. If we pick apart this conceptual diagram, at the top right is the connection broker. It is not a hosted service. You install it, and you can install it just about anywhere, on-prem, in the cloud, really whatever works best for your environment. And what does work best is to put it somewhere where it can communicate with all of your Leostream agents, which you see there residing on the desktops at the bottom. Broker communicates with the agent on port 8080, but that's completely configurable by you. Agents always communicate with the broker on 443 for a nice secure connection. Your agents and brokers are typically tucked away somewhere on a network that is not accessible by the users and their clients when they're remote. Your users and clients are over there on the left. So in between them then is the Leostream gateway. It serves two purposes. It sends login traffic on 443 from the user's client to the connection broker, so the broker can authenticate the user and implement your access control rules. After the broker returns a list of the user's permitted resources, the user requests a connection to one, and now the gateway switches tasks and tunnels the user's desktop connection. Except for its built-in HTML5 viewers, the gateway sends desktop traffic by manipulating its own firewall to direct that traffic explicitly from one client address to one hosted desktop address. It conceptually is an automated enterprise NAT using kernel-based port forwarding for the traffic. And that places very little load on the gateway machine to avoid the performance hits that you see on VPNs. So the gateway is crucial for remote access, and it gets a lot of glory here lately. But if you're like me and you like control, the connection broker is really where it's all at. So now let's look at that and see what it can do, which brings us to our demo. So I'm going to switch to sharing my screen. So what you're looking at here is the web interface for the Leostream connection broker. It can be used by administrators, which is how I'm going to sign in here in a second, and it can also be used by end users. This is completely customizable. We had a recent video that showed you how. There's some documentation, change the layout, change the colors, make it your own corporate brand. So I'm going to hide that, and now I'm going to sign in. So the way the connection broker interface for administrators is set up is essentially these menus down the left. And when we tell people when you're starting out, what you're going to do is you're going to start at the left and just kind of work your way down. I'm going to start in setup and kind of highlight some of the features that we've been talking about in this presentation. Let's start by looking at authentication. Leostream supports a wide range of authentication methods. Yes, Active Directory is one of them for username and password. We can also use any authentication server based on Open LDAP and even NIS if you happen to have old Linux systems out there. So here I have an Active Directory server for my demo environment, but then I have also hooked this up to Okta as a SAML-based IDP. So we have documentation on how you do this, but you basically set it up so that the broker redirects users when they try to log into Leostream over to Okta, and Okta handles the authentication and sends a SAML assertion back to Leostream to finish the login process. Now, there's two ways you can work with SAML. You can have it be the blanket login page for your broker. Nobody gets to use username and password entered into Leostream. They have to go to your SAML-based IDP. But in some cases, what we've seen is that people want to enforce logging in through their identity provider for remote users, but the internal users can actually use username and password. So there's an option here to enable user logins at a special URL. So you can direct internal users to that URL, and external users automatically get redirected to the external URL. And I'll show you how that works here in a bit. So you can have all these different types of authentication servers. If you have multiple domains, you can have multiple Active Directory servers. They all function independently in here when it comes to policy assignments. Now when I start showing you end user logins, I'll show you again through SAML. I'm going to show you an Active Directory username password login. But there is, even if I'm using Active Directory username password, a way to enforce MFA. And that's by defining an MFA provider here. Leostream has native integration for Duo, if you happen to be using Duo as an MFA provider. And we can also talk to any identity provider, as I mentioned, that supports the Radius protocol. So here I've installed a Radius agent, and the broker is talking to the Radius agent here, which proxies the traffic over to Okta. So again, I can use one-time tokens or push notifications as a second factor for users there. Moving on from authentication, we talk about centers. I mentioned you might want to start thinking remote access, building yourself a hybrid cloud environment. Maybe you host your DR up on the cloud while using your on-prem resources for normal day-to-day business. You put Leostream in front of those, users keep logging into the same portal and just fail over seamlessly to whichever environment they're going into. Here you see in my particular demo environment, I am hooked up to all of the big three clouds, Google Cloud Platform, Amazon. Oh, I guess I didn't connect to Azure. You can connect to Azure. We do support a wide range of different center types here. And essentially, if something is listed as a center, that means that we integrate with the native APIs that platform provides. So we can inventory what you have for cloud environments, virtualization environments. We can also automate provisioning. So you can actually automate the expansion and collapsing of that capacity. The last point in setup I'll show is the gateway tab here. So the Leostream gateway, as you saw in the architecture, it's a separate machine from your brokers. Your brokers tend to be locked in your network. The gateway you put in a location, maybe a DMZ, where both the user's clients, if they're remote, have access to it, and it can tunnel the connection through to your remote desktops. There's very little configuration that you do on the gateway then. It does have a small CLI for doing some tasks. But mostly what you do is you just come here in the broker and you add the gateway into the broker to register it with the environment here. If you have multiple gateways, which you see I do have here, you can create what we call gateway clusters. So this gives you a way to kind of scale out the environment. You just build out additional gateways and then add them into the gateway cluster behind a load balancer. So in the setup section, you are hooking Leostream up to all of the external systems that are in your environment. In the configuration section, here's where you start building those access control rules we've talked about. And what you do is you start by building pools. Pooling in Leostream is very, very flexible. So essentially build pools in the way that works best for you. I happen to create one pool, which is based off of a center. So it's all the machines that are in that particular cloud. And then because I want to show you some additional protocols, I've created subpools based on machines that support different protocols. But you can create these however works best for you. Maybe it's all the machines on a certain subnet. Maybe you have a naming convention. Essentially, think about how you need to control and restrict access to machines and then build the pools according to that. The pools also are responsible for the automated provisioning. So it's inside the pools where you'll tell the broker, how do I provision out more machines and when do I do that? That can be based on static limits. It can also be based on time of day. Protocol plans then are where you tell the broker once a user has successfully authenticated and been offered their machines from their pools, how do we connect them? As I mentioned, Leostream does support a wide range of display protocols, and this form is basically chunked into sections based on the client type. So are they using our Leostream Connect software client? Are they logging in from a web browser? Is it a TerraDT client? The types of protocols we can launch change based on the type of client. Obviously, can't launch an HTML5 connection from Leostream Connect. So here you see all the different types of in-browser options that are currently available. Leostream HTML5 viewer is built into the gateway, and as I mentioned, supports the three protocols, RDP, VNC, and SSH. If you need a more performant connection, you can look at one of the third-party HTML5 viewers, which are new in the 9.040 release, which has put out. That includes No Machine, Nice DCV, which is a nice option if you're running in Amazon, as it does come free with your Amazon licenses. And then Skilled Cloud Workstation HTML5 Viewer is a new option that we just added. It's provided by Penguin Computing. Also great for in-browser connections. You'll notice these connections these protocols that support in-browser options also have client-based options. And what I mean by a client-based option is essentially we launch the software client that connects to the remote desktop on the end. So many, many options. Again, you can mix and match these through the broker, so you can have some users connecting through RDP and only invest in the highly performant protocols for the users that need them. Power control plans I want to point out because they're particularly important when you're looking at using the cloud. Leostream allows you to model non-persistent workflows in the cloud, so you actually delete the cloud instances when users are done. That saves you on the compute cost and saves you on storage costs. But if you have persistent machines in there, you still want to save on compute, and you can do that by automating power state. So here is where you start to see the Leostream agent come into play. These are the events that I mentioned are coming from the agent. Did the user disconnect? Have they logged out? Did they go idle? Power control plans allow you to automate the power state. So perhaps when they log out, 1 minute might not be long enough. I'll give them 5 minutes. If they don't log back in 5 minutes, I'm going to go ahead and shut that machine down. Again, saving compute costs in the cloud. You can then offer stop machines to users and we'll power them back on before connecting to them. Release plans then define how long does a user own an asset after they request a connection to it. And here is where you have a lot of flexibility to define not just a non-persistent workflow or a persistent workflow, but pretty much everything in between. So just as an example, again, you notice this form broken into sections based on these events that come from the agent. The way this plan reads is if the user disconnects, okay, give them an hour. And if they don't reconnect in an hour, then we're going to forcefully log them out. And essentially the broker sends a notice to the agent, hey, forcefully log that user out, and then they're gone. That logout event then triggers this section of the plan. So whether the user logged themselves out or we do it automatically, then the machine gets released back to the pool, which means it's now available for somebody else to use. That a release event can trigger its own actions down here. And here is where you could be able to say, if the user logged out and they released the machine, then I could go ahead and delete the machine if this is a non-persistent workflow, for example. You see there's also options here for when the desktop is idle. Maybe you want to have layers, lock after 5 minutes, disconnect after a half hour, log after an hour. You can decide how you want to model those. So you can see by one event triggering the next, and with all these different options here, you can really fine tune how long a user owns a resource and really model all of the different business rules that are important for your particular organization. To bring the pools and the plans together, that's where we start talking about policies. Ultimately, when the user logs into Leostream is authenticated, Leostream assigns the user a policy, and that determines which pools they have access to. So if I look at an example pool here, this is a pool that's offering 2 different types of machines. One that we're going to connect to using no machine, and the other one that we're going to connect to using DCV. The offering of desktops from pool is down here in the desktop assignment from pool section. So I'm offering 1 machine from my no machine pool. And then a lot of these other options, they help the broker kind of hone in on the best machine from the pool. Can I offer a stop machine? Does it have to have a running agent? Things like that. For certain protocols, I mentioned collaboration earlier. For protocols that support collaboration, and you see there's a pretty good list of them, we allow users to send invitations to other Leostream users to collaborate. And you see I've got that feature enabled here for no machine. And not only can they collaborate, but you can actually limit which users are they allowed to offer to this for this particular, how do I want to say this? Which users is a particular user allowed to invite to collaborate on their session, if you followed that. So basically by setting up different groups, I can restrict who users are allowed to invite for collaboration. Now, a policy can offer as many desktops from as many pools as you want. Here, I'm also offering 1 machine from the DCV pool. We don't have the collaboration enabled for DCV just yet, but that's coming up in a soon release. Now you notice these protocols are all going through the gateway. So this is both DCV and the no machine connection are going through the gateway because that's the protocol plan that I've selected. Now, before I show you how these policies get assigned out to users, I want to talk about locations, because locations, particularly when you're talking about supporting both users on-prem and wandering around and accessing remotely, locations become important. Locations allow you to tailor what the user has access to and even what level of authentication they're required to pass through based on where they come in from. So just like pools are completely flexible how you want to define them, so are locations. It can be a physical location, it can be a group of client types, whatever you need. So for my example, I've created one location, which is all web browsers. And then just so I can kind of mimic someone remote versus someone local while I'm obviously only in one place, I've created an on-prem web browser location that says, well, this is my subnet, and it's not anyone who's coming from Firefox. I'm on Firefox right now. So Firefox is going to be on-prem, and I'm going to launch another connection from Chrome, and we're going to pretend that's my remote user. Obviously, there's better ways to do that. If you really are remote, you can do it based on the IP address range. It could be a sitter. So for your users on-prem, you know your network IP address range of your local clients, and so you can create a local network location that way. Just for kicks, let's talk about roles a little bit too, because I did mention collaboration. There is a role option that you need to tick on if users are allowed to collaborate with one another. So the whole idea is to lock functionality down unless you enable it. That's true for allowing users to reboot their own machines. If you are offering stopped machines in the cloud, you might want to allow the user to say when they want to power it on and off. You have that ability there. So finally, this all comes together in assignments. Now, if you remember the authentication server page I showed at the beginning, it had two rows, one for my AD demo environment, the other one for Okta. You notice I have the same two rows here. So I mentioned for each authentication server you independently define the rules that indicate what policies users are offered to and roles. So if we read through this, how this reads, essentially when the user logs in, the broker starts at the top and works its way down, and the first row the user satisfies determines their role in policy. So here, I'm using any group. You would obviously define groups for which users have access to different pools. But based on who the user is and those locations that we talked about, that first of all says, well, do they need to go through an MFA provider? And again, this is one of those Radius or Duo providers. Assuming all of that passes, then they get their role in the policy. So here, I'm going to show you logging in with an on-prem web browser, and that's going to give me a particular policy, but not require MFA. If I log in from our Leostream Connect client, though, I'm going to fall down to this third row that is going to require MFA, and then I happen to have it set up to give me the same policy, but you can do whatever you want there. Now, if a user falls through all of these rows, you come down here to the default, and here you can actually prevent the user login entirely. So this gives you a way to say, hey, I'm going to create very locked down groups in Active Directory. I'm going to assign users to those specific groups, and anyone else doesn't get to log into my Leostream environment. So before I start showing you this in action, I want to show you the system log page. I mentioned audit level tracking. Let's set a marker so we can see where we're starting. So this page gives you a running tally of everything that's going on in the system. Who's logging in, when they logged in, what did they connect to? You see it all here, and then you can pull this information out to create reports. We are currently working on some pretty fancy dashboard functionality for the broker itself, but right now all this information is available. Our reports are going to be generated off the exact same information that you have available to you now. All right, so to see this in action, let's start by showing the SAML example. So here, I'm pointing to, this is essentially the address of my load balancer, but it's whatever is the IP address or host name that you're using for your main Leostream login. Now that, once SAML is enabled, automatically redirects me over to that particular SAML provider. I've seen this work with a variety of different systems. I'm going to log in here as Milo, or not. This Milo. I'm with autocorrect sometimes. So what happened there is Okta validated the person. If Okta had required MFA, it would have prompted for that. And now I see my connections here. So now I can go ahead and connect to, for example, this DCV session. So this will launch a connection in a new tab because that's how I have it configured. And it's launching the connection in browser using their HTML5 client. So you can see it logging in here. So that's just an example of a DCV connection. Now remember, this was a SAML login. I just connected DCV. I can actually also come in here and launch the same PC over IP connection here. Now remember, because it was a SAML-based login, the broker doesn't have a password for the user. To connect to the Windows machine, I need a password. So it opens the login dialog. I click login, enter my password, and then it'll launch the connection to the desktop. There it is, opening very full screen. Let me just sign out of that so we can get back to our system. So refreshing the log page here in the admin portal, you see all of that going on. So Milo logged in. Where's Milo's logging in? Milo's logging in, got his offers, requested a connection. You see this was a connection that was forwarded through the gateway. So there's the port forwarding being added into the gateway. Let's come in here and sign out now. So I'm going to sign out of that. And now if I refresh my log, we'll start to see the port forwarding rules being removed from the gateway. So there it is going away. So the whole idea is that connection is only there and allowed during the time that the user is actively connected. You see all the agent notifications coming in. So that's an example of a SAML-based login. Now let's talk about what about our local users. Well, here I have too many tabs now. I mentioned I showed you that checkbox where we allowed people to come to the /login URL and log in using username and password. But we restricted that for local users, which we're calling people coming in from Chrome. So here, Mabel's going to try and log in, and it's actually going to fail. Now, we just give the user a generic invalid username and password error, while you on the broker logs would see a little bit more information about why did that connection actually fail. And again, that's security reasons. If someone's coming in and just hacking on this, you don't want them to know, oh, hey, go to Chrome or whatever it is that whatever the real reason was. So now let's switch to Chrome. And now you'll see that she's able to log in just fine. And again, no MFA required there. Just to show you our Leostream Connect client here. Where's my cursor? So this is our Leostream Connect client on Windows, obviously. As I mentioned, it does also run on Windows or Linux and Mac, I should say. So now I'm going to log in. And here for Leostream Connect, it's asking for the MFA. So I'm going to go ahead and request a push. And that's going to send a little thump to my watch here, which I'm going to say yes. And now I get logged in. So I can actually come in here. This, again, is going to launch client-based protocols. So if I click on that machine, it's going to launch the no machine client. This is, as I mentioned, one of the protocols that we added support for the HTML5 client in the latest version of a broker. So if you come from a web browser, you can actually launch this connection in the browser. Sometimes it takes a little while to load there on me. Okay, so there's that. Again, everything being logged here as it's going on. All right, I think I have probably said enough. I think it's time for you guys to chat. So I'll let Megan take the lead, tossing out questions at me.
Perfect. Thank you so much, Karen. I have several questions here. I'm going to start with the first one that came in. How many connections can one gateway handle?
The number of connections that a particular gateway can handle, actually, it depends on a few factors. One, are you using our built-in HTML5 client? If you are the gateway, make that gateway as beefy as you can with CPU, and you'll be able to tunnel fewer connections through it because of the HTML5 client uses Java, so it's just taking up a lot of CPU. If you're doing the port forwarding, again, as I mentioned, that's very efficient kernel-based port forwarding, so it places very, very little load on the Leostream gateway. So now what you're talking about when it comes to number of connections is the network. How many connections will your network actually handle before you start to see degraded performance? So again, there's a lot of different factors. I've talked to people who said that they've actually maxed out at around 80 connections. We say you can probably get to about 100, particularly if you're doing port forwarding, maybe not with the HTML5. Keep in mind that the performant HTML5, the No Machine, the DCV, the Skilled Cloud Workstation, those are actually done. They're in browser, but our gateway is not doing the rendering. It's actually just doing the port forwarding. So those can be considered one of those more highly efficient port forwarding protocols, even though they are in browser. So again, the answer, of course, sadly, is it depends, but it is very easy to add additional gateways to your environment if you want more than one just for DR, but you just keep adding more as you scale up.
Perfect, thank you. The next question is, can I use Azure MFA with Leostream? You
can. That is when it works great through the SAML method that I showed you. So I happen to do Okta, but we have seen people using the Azure AD and MFA using the SAML-based interface. Seen a few others as well, but I believe we posted a little how-to video, might have just been yesterday.
Perfect. Next question, is there any functionality to help me model a classroom workflow?
Yeah, so what we added in this release, which I neglected to show you, was the ability to schedule access to particular pools. So by default, the user logs in, I saw my offers from my pool. What we have now is the ability to say, I logged in, it's 1 p.m., I don't yet have access to this pool because the class starts at 2. But at 2 o'clock, for different groups of users, as an example, 2 o'clock, you can enable access to those particular pools. So basically it's scheduled access. You create pools that mimic your classrooms, and then you create schedules in the policies that mimic the class schedules. As far as logging out, we're working on a little bit better functionality for logging people out when the class ends. We didn't want to just magically close connections on people because that would be terribly disruptive. So we're working on functionality to send notices to people when the class is ending and things like that. So they can be warned, hey, you're about to lose access to this machine in 5 minutes, save your work.
Okay, perfect, thank you. Mm-hmm. Is the security gateway now supporting PC over IP software agents and not just the PC over IP workstation cards?
So currently our security gateway is still the remote workstation cards. You use the Teradici PC over IP connection manager and security gateway to access the cloud access software. When I launched my PC over IP connection here, it actually went through a Teradici PCM security gateway. And I didn't, I can't share, I'm not sharing my screen anymore. I didn't show this, but in the protocol plan, you tell the broker where's the security gateway that this is associated with this protocol plan. So we know where to send people.
Fantastic. Is the Leostream Connect support single sign-on protocol like Remote Boost Nice DCV?
For single sign-on, there's a couple different ways that can work. And once you're talking about SAML, then pretty much none of them work because we don't have a password to handle the single sign-on. So for Remote Boost, they have their own credential provider. When you install the Remote Boost sender, you can tick on I think it's called Enable Single Sign-On. And then what happens is Leostream would in fact pass the username and password, if we have username and password, on to the Remote Boost receiver, which would then send it to the sender, and the user would have nice single sign-on to the operating system. For Nice DCV, I know you didn't see single sign-on here in the example that I showed, but we do support that through a couple different ways. Our agent does provide a credential provider. So if you install our Leostream agent on the machine with its credential provider, then when the broker establishes the connection, it'll send the credentials to our credential provider to perform the single sign-on. So we have that support essentially for console-based protocols. So for nice DCV console sessions, or even for no machine console sessions, our agent can handle the single sign-on if the broker has a password to send. Again, with SAML, we don't, but with normal Active Directory logins, we do.
Perfect, thank you. The next question, can security gateways be spun up and added to Leostream on the fly?
Oh, did I talk to this person yesterday? We were actually just talking about this yesterday because we have been hearing more and more requests for automating those types of tasks. Right now, it's done through the UI. You can spin up the gateway, which is fine, but then you need to register the gateway with the broker. And so that's the part we're working on, is some way to automate via scripts the attaching of gateways to brokers. Literally yesterday we were talking about that.
Fantastic, timely questions.
Yeah.
Is it possible to script the steps outlined so a site can be quickly configured?
Oh, another one we were talking about yesterday. We had our product meeting yesterday. So what is actively under development, and there's some in here now, is a new RESTful API. And we have an XML API. It's fairly limited and mostly tailors around querying information out. We're building a RESTful API, and it is going to allow the broker configuration to be fully scripted. Right now, in the version that's out, I believe there's an API to create pools and some, log into the broker, create pools, I think a little bit related to users, but obviously not scripting this entire, I should say building a script for this entire interface is a pretty big task. So we're working our way through it over the course of this year. Actively under development is the policy API. So that'll be in the next release.
Fantastic. And this last question that I have here is, the Leostream Connect support smart card authentication? Is the Leostream Connect support, I think it means, does the Leostream Connect smart card in authentication?
I gotcha. Yes and no. So there's a couple different ways to use smart cards with Leostream. If you're using Teradici 0 clients and you have PIV or CAT cards, so we have a lot of organizations in the federal space, so they have these standard PIV CAT cards. You can do a really nice smart card authentication using those PIV and CAT cards for PCoIP 0 clients. If you're talking about Leostream Connect and you're looking at our Windows client, it can do what I call smart card identification. We can read the smart card to figure out who the user is, but we don't do official verification of the certificate and everything. What we end up doing is, and this also assumes that there's a USB pass-through that allows the smart card to be passed through to the remote host. So after we identify the user and know what resources you've allowed them to access, we can pass the smart card, well, your protocol technically does it, passes the smart card onto the remote host to actually get the PIN and do the validation of the certificate. So it's more smart card identification than it is authentication for Leostream Connect.
Fantastic. And that seems to be all the questions that we have for now. You answered through 8 of them.
All right. Well, in that case, you want to wrap us up, Megan?
Yeah, absolutely. Thank you, everyone, for joining us today. Keep in mind, you can get a free trial from leostream.com. You can also reach out to me and the rest of the sales team at sales@leostream.com if you have questions on pricing or anything that wasn't reviewed here on the demo today. Thank you so much for your time, and enjoy the rest of your day.